So this is the worksheet on atoms and subatomic particles that we're gonna finish. So these particles on the outside, this is we're using Bohr's model of an atom, where you have this nucleus, and then you have kind of these things orbiting around, which we'll get into what those are. So we have these electrons that orbit. They kind of go, not necessarily in circles. These are kind of simply drawn, but we have these electrons, these orbits, these orbitals. So these blue things represent the electrons on the outside. Now, this thing here in the center, we call this a nucleus. Kind of like in biology, the nucleus is like the center, kind of close. This is the nucleus of an atom. We have two different particles in the nucleus. One is going to be neutral and one is positively charged. These neutral particles in the nucleus we call neutrons. And these positive particles we call protons. So neutron for neutral, right? Kind of in the name a little. Protons are positive. Electrons are negative, which I'll talk more about in a second. Things out here are called orbitals. Where these electrons kind of orbit around the nucleus of the atom, hence the name orbital. All right, so going to 2, it says fill in the chart. So for a proton, the relative charge is +1. The protons have a positive 1 charge, is what we say in this. So protons are positively charged, neutrons are neutral, and electrons are negatively charged. Now we have just as many protons in our atom as electrons for ground state atoms, or atoms that are in their natural kind of form. So the number of protons will be equivalent to the number of electrons, and this is to kind of balance out the charges. This should say relative mass. The relative mass of a proton, we say, is 1 AMU. Neutron is also 1 AMU, but the electrons, even though they're drawn pretty big here, the electrons essentially have no mass relative, right, to these other things. Electrons do have a weight. However, it's just very small. So we kind of say it's relatively 0 to the other two. What is an atomic number? So the atomic number, if you're looking on the periodic table, it's kind of the little number above the symbol. Right? The atomic number refers to the number of protons in the nucleus. And I think I'll just type this out. I think that would be better. It refers to the number of protons in the nucleus. And this also determines the identity of the atom. So atoms have identities, right? Their names are based on the number of protons they have, not on the number of neutrons, not on the number of electrons, but on the number of protons that they have. So that's what this means. We give them their names based on the number of protons. What is a mass number? So the mass number of any atom is going to be the number of protons and the neutrons added together. So when you add you have a certain amount of protons and neutrons, you add them together, you get the mass of the atom, right? So because the electrons don't weigh anything. So we add up the total mass of the protons with the total mass of the neutrons. Number 5, it says identify the atomic and mass number on the diagram below. So the atomic number is right up here, and that's just a 6. Which means that this has 6 protons. And the mass number here is 12. So oops, I'm supposed to label it like this. Atomic number and the mass number. So the mass number is found below the element symbol. Now, if you're wondering why it's not perfectly a number, right? If there's neutrons and protons, and you always have an integer amount, right? 10, 20, 30. Why is it 12.001? I'll talk about that in the next worksheet. So number 6, it says, based on the information fill in the table below. So this first one, helium. The atomic number is 2. You need the number of protons. This has 2 protons, right? The number of neutrons, we can take, we have a formula, right? Number of protons plus the number of neutrons is equal to 4, right? Or let me make it more general, is equal to the mass. So I have 2 protons plus some number of neutrons is equal to 4. So I must have 2 neutrons for this first one, right? We're essentially subtracting the number of protons from the mass number. So this is a 2. And as I said, it's going to have the same number of electrons, right, in these kind of elements. Not ions, we're going to have some other, we're going to have different numbers of electrons, right, from our definitions, but these are just the normal elements. Sodium, the symbol is Na. If you look on the periodic table, it's in group 1. The atomic number is 11. The mass at the bottom is, well, let's see, right, for this specific sodium. So for this sodium, we have 11 protons and 12 neutrons. So it has a mass number of 23, right? I'm adding them up. You'll find that we have atoms with the same number of protons, but different numbers of neutrons. They're the same type of atom. We call those isotopes. That's why I'm not looking at the periodic table. We're looking at this specific sodium atom with 12 neutrons and 11 protons. Okay, next is oxygen. The atomic number is 8. And looking at the periodic table, the number of neutrons in this one is 8. 16 minus 8. Also, number of protons here is 8. So the atomic number has to be 8. And we have 8 electrons. Has to equal the number of protons. Xenon has an atomic number of 54, which means it has 54 protons. The mass is 54 plus 77. So 131. Also, what you could do is there's 54 electrons. So it has to be 54 protons if this is neutral, which they are in these examples. They're not ions. Silver, the symbol is Ag. The number of protons is 47 from the atomic mass number. And the mass number is, sorry, the atomic number, not the mass number. Atomic number gives us the protons, and then the mass number, we can take this and subtract 47 to get 61. Next, we have barium. So barium has an atomic number 56, right? Same as the number of protons. 137 minus 56 gives us the number of neutrons, which is 81. And then we have 56 electrons to be equal to the number of protons. Next, we have potassium. Potassium is K, atomic number 19. Mass number of potassium, let's figure it out. So the proton number is 19. We have 20 neutrons, and we just add them up. So this is 39. We have 19 electrons to be equivalent to the number of protons. Manganese, symbol is Mn. The number of neutrons, mass minus the number of protons, 55 minus 25 is 30. And the number of electrons is 25, again, equivalent to the number of protons. Sulfur has the symbol S. You have to look at the periodic table for that. The number of protons is 16, and the mass is 32, 16 plus 16. So that is it for this worksheet. Hope that helps, and see you on the next worksheet.